This is station review number 8, and we have a triangle here. There's a site they're digging, and so it's not a right triangle. That's the first thing you notice. And so we have two choices. We have sine rule and cosine rule, or law of sines and law of cosines. The way you decide is, do I have an angle side pair? Do I know the side across from an angle, which I don't. And so if I don't have an angle side pair, I know it's law of cosines. And even though this triangle is already labeled ABC, I know I'm going to be able to find this side. So I'm going to call that C. So C squared. So A and B, it doesn't really matter. You can call them whatever you want. I'm going to call that A. That'd be 185 squared plus 250 squared minus 2 times 185 times 250. It's hard to see that, 2 times cosine of my angle, which is 125. I'm going to put that all in my calculator and do that in one step. So 185 squared plus 250 squared minus 2 times 185 times 250 times cosine of 125. The only thing I didn't check was to make sure my calculator is in degrees, and it is not. I turned it off. So now I need to do second enter and bring that back up. So I have 149,780. I'm going to take the square root of that. So 387 is the distance from A to C. So then we keep going, and I'm going to bring that 387 down here to my picture. That's where it is in the picture. And we have two more paths. And so they want us to find the size of the angles BAC and CAD. So I need to find this angle right here and this angle right here. I'm sorry, BAC and CAD, this one. So to do that, I know they add up to 85. I need to find one of them. So again, I ask myself, do I have an angle side pair? In this case, I do. So I can use law of sines. So 387 over the sine of 125. Take it off that nifty pen. Equals 250 over the sine of theta, which is what we're finding. So I can solve it on my calculator. 250 times the sine of 125, it equals, divided by 387. And then because I'm finding an angle, I have to do inverse sine of my answer. 31.9. That's angle BAC. So to find angle CAD, I take 85 minus 31.9. Which is 53.1. Then it says find the size of angle ACD. So again, we're going to go up here. I'm going to erase some stuff. Put things on my picture that I know. So I'm talking about this triangle now. And I know that we just found CAD. So this is 53.1. Let's draw that triangle out here. and this is 387. And so I could use some more information here. Well, I need another angle. And so I have a quadrilateral here, which all the angles add up to 360. So I could take 360 minus the angle. So minus 85, minus 125, minus 70, and that would give me that top angle is 80. So now I can find angle ACD because in this triangle, these three angles add up to 180. So 180 minus 53.1 minus 80, 46.9. So I basically found almost every little tiny angle. The length of the path AD to AD is 287. So I know this is 287. Also on this right here. Find the area of the region ABCD. That's two triangles. So I know the angles in my triangles. I knew this angle was 31.9 right here. So to find that this lower triangle, I have a side, an angle, and a side. I can do 1/2 the 185 times 250 times the sine of 125. That's the included angle. That'll give me the bottom one. And the top one, I can take 1/2, and I'm going to use this side angle side. So that is, it's hard to read on that there, 287 and 387. And the included angle is 53.1. Okay, so we'll punch those in. Make sure you're punching these in the calculator yourself. So that's the first triangle plus the second triangle. And if you put it like this, it'll do order of operations. You might break it down in steps on your paper. There's your area, 63,352. There's no rounding needed. You leave it, so 63,400 if you're doing 3 sig figs.